Imagine you are building a student management system. Every student has a name, roll number, marks, CGPA, and branch. So now imagine managing all this data using separate variable for hundreds of students. Sounds messy, right? That's exactly the problem we will solve today. In this episode, you will learn structure in C++, a feature that helps and that lets you group related data into one organized unit. We will cover everything from creating your first structure to array of structures, nested structure, function with structure, and real-world examples. So, welcome to ShivCore. As we say, master the core, build the future, and let's begin. So, episode 14, structure in C++. So, structures help us organize related data into one meaningful unit. Learning objectives, like by the end of this episode, you will learn why structures are needed, how to create structures, structure members and variables, the dot operator, array of structures, structure with functions, nested structures, real world applications. So, moving ahead, the problem, can one variable store a student? So the scenario, you are building a college management system. Every student has name, roll number, age, CGPA, branch, email, phone number, etc. So can a single int store all of this, or a float, or a string? Obviously not. I mean, how can it be done? So key observation here is a student is not just one value, it's a collection of related information of different data types. Similarly, real-world objects usually contain multiple pieces of related information. So, if one variable is not enough, then what should we use? So, our array is the solution. Exploring why arrays fall short for complex data. The array approach, that suppose we create separate arrays with string names 100, int roll numbers, float CGPA, string branches. Student hashtag 5 would be names 5, roll 5, CJ 5, branch 5. So we must manually keep indices in sync. So why this fails is that if one array becomes unsynchronized, the entire student record breaks. Disadvantage here is difficult to maintain, hard to understand, error prone, poor scalability, cannot pass one student to a function, and no logical grouping of data. So the key insight here are arrays organize similar data. They cannot organize different types of related data about one subject. So we need something that groups different data types together. So array organize similar data, not different data types of related data. So we need a better way to keep all information together. So what that solution for this thing will be? So real world examples that need structures are student, as I explained, similarly employees or patients or car, because all have their a list of things which are in int, float, double, bool, etc. But we can't make and arrange for each of it separately. So key observation here is each object has many different properties, yet we think of it as one object. So programming should represent real world objects in the same way. So this is fundamental motivation behind structures. So programming becomes easier when code mirrors the real world. So how can C++ group all these related pieces of information together? I mean, here is structures. So the need of structures, like a structure is a user-defined data type that allows us to group variables of different data types under one meaningful name. So definition, a structure is a user-defined data type that allows us to group variables of different data types under one meaningful name. So why structures? Because instead of creating multiple unrelated variables, we create one structure that represents one complete real-world object. Advantages: better organization, improved readability, easier maintenance, cleaner programs, models real-world entities naturally. So simply the concept flow here is separate variables, problem, no grouping. Solution: structures, organized object. So key takeaway: a structure groups related data, not unrelated data. It doesn't create new kind of data, so it organizes existing data into meaningful units. So structure don't create new kinds of data, they organize existing data into meaningful units. So we will learn how to create our first structure using the struct keyword. So firstly, let's understand the struct keyword. So struct keyword creates a new user-defined data type. Unlike int, float, char, structure combines multiple variables into one logical unit. So syntax like struct student, simply struct is the structure here, student is the name of structure, and inside the curly braces is the content which should be present. Simply you can understand here also, as in breakdown, struct tells compiler we are creating a structure, whereas student is the structure name and the curly bracket contains all the members and colon marks end of structure definition. So one important observation you have got, that creating a structure does not create any data, it only creates a blueprint. So struct student big forms a blueprint, not actual data. So no object exists until we create a structure variable. A real life example can be taken as house blueprint. So if a blueprint describes how a house should look, but no actual house exists until it is built. So similarly, a structure describes an object, but no object exists until we create a structure variable. So if a structure is only a blueprint, then how do we describe what belongs inside it? Structure members. Placing related variables inside a structure. So example, student structure. Here the structure student has string name, int, roll number, float, CGPA, char, section. So each variable inside is called a member. So member describe properties of one object. If we go to detailed breakdown, the name here is student's name, and then roll number is student's roll number, CGPA is student's CGPA, section is student's section. So key observation, members can have different data types. That is the biggest advantage of structures. Important note, members behave exactly like normal variables, they simply live inside a structure. Student profile card. A student profile contains multiple fields. Every field represents one member. So if profile card is name field, it is string with name. Role field has int with roll number. CGPA has float with CGPA. Section has char with section. So a structure is simply a collection of related variables called members. So we have created the blueprint. Now let's create our first actual student. So now let me move you to VS Code screen, and here we will be doing our first structure code. Hashtag include int main return 0. So inside here we will simply say student S1. So this is student S1 is the structure name. We will say simply S1 dot name is Shivansh. S1 dot roll number, let me say for roll number, let me say any number like 101. And now the third thing, I will say S1 dot CGPA and I will set it to 9.00. So here it is. Now firstly let me create the structure student. So it will be done above this. I will say struct student here. So this structure is done. There is no curly brackets included in the structure. That's it. I will simply say string name int roll and int cgpa roll number. So after making this, we will simply add colon that marks the end of the structure, and here I will simply say cout. Here I will say s1 dot name, not just name, s1 dot name, and then end of line. And here I will say cout cgpa and then I will say s1 dot cgp and end of line. It's s1 here. Yup. So that's it. We are done with our code. Now when I run the code, it won't show anything because I haven't asked it to print something, because it's just just the code for the structure. So this is the first structure program. I hope you all have done it. So on running the code, we get name, roll number and CGPA like this. I have run it 2 times. It has given me output 2 times. This is our output, which is totally correct. So commenting all of it, and now coming back to our presentation. So next we have creating structure variables. So creating variables from structures. Just like variables are created from data types, structure variables are created from structures. Example student S1, student S2, student S3. So explanation array student is the data type, or you can say structure. S1, S2, S3 are variables, or you can say objects, and each stores independent student information. So in comparison of int A, int B, student S1 and student S2 is taken. So important observation for you is Creating multiple variables from one structure is similar to creating multiple integer variables. So each variable is completely independent. Modifying S1 does not affect S2 or S3. Such a best thing. All variables share the same blueprint but hold different data. So one structure can create thousands of independent objects. Now that we have created a structure variable, how do we put information inside it? So accessing members, the dot operator, very important. So how C++ reaches inside a structure variable is by using the dot operator. So every structure variable contains multiple members. To access a specific member, use the dot operator. Example s1.name, s1.roll number, s1.cgp, s1.selection. So the dot operator tells C++ to go inside the structure variable and access one specific member. Important note: dot operator accesses members. So different objects have different member values, and one member can be modified without affecting others. So how this generally works is S1 goes to student object like name, roll number, CGPA section and access specific member like S1.name. So real life analogy, like think of a house. So house has room, room has cupboard, cupboard has drawer. So the dot operator helps you reach the exact information you want. I mean step by step. So the dot operator acts like a doorway into a structure. Great. Now let's learn how user can enter information into a structure. So taking input and displaying output using cin, getLine and cout with structure member. So input and output example. Structure members behave exactly like normal variables. They use cin, getLine and cout. Like here is if input is cin s1.roll number and then getLine cin s1.name. The output is cout s1.name, cout s1.cgpa. So every member can be read and displayed independently. They behave like ordinary variables even though they belong to one object. But the important note here for all of you is that use getLine for names containing spaces and use cin for numeric values. Always access members through the dot operator, and each member is independent of others. Order of input does not matter. A quick workflow for all of you is that create structure variables, access members, input data, display data, and this is the complete cycle for using structures. So structure members are accessed exactly like normal variables with the help of dot operator. And now that we can create and use structures, let's explore how they are stored in memory and how to initialize them efficiently. So as I have explained you that you can use cin and getLine to work with this. So this is very important, and let me show you this also in VS Code. So coming to VS Code now. So hashtag include IOStream namespace standard int main return 0. So here for the question Let me firstly make a structure named student again. I will say string name int roll, and one more thing I will add here is CGPA. I will say int CGPA. Actually, I will take it float because CGP is also in points, and this will mark the end of the structure. Continues next, we have inside int main we will say student s1 like this. No, student s, and after this student s we will say cout, enter name, and we will take it as s dot name. So after taking the name, the similar way we will do for role and CGPA. So enter role, so after declaring all of these three, we will simply say cout slash and then student details here. For the student details we have written this student details, and after this we will simply do one thing, that after this we will add a slash n also here, and after doing this we will simply say cout s dot name handle. So that's pretty much it. We are done with our code, and when I run the code, enter name, I will say Shivansh, enter roll number, I will say 10001, CGPA 10. So simply student details comes here with name Shivansh, the given CGPA and roll number in the same format, and we are done. It is very nicely done. It's correct also. Commenting all of it. And now coming back to our presentation. So how structures are stored in memory? So understanding memory layout of structure objects. Memory layout explains a structure groups multiple variables together, but how does the computer store them in memory? So every member occupies its own space inside RAM. So the complete structure occupies one continuous block of memory. Like see this memory layout inside student object. All of this name with string, roll number with int, CGPA with float, section with char, all is stored in one block, and that's how structures are stored in memory. So although every member has a different data type, they are stored together as one complete object. Important observation is that every object has its own memory block. Members are stored sequentially, and accessing one member does not affect others. Some common beginner mistakes for you are many students think a structure stores only one variable, but actually it stores several variables together. A real life analogy of it is locker. So think of a locker. Inside one locker there are multiple compartments, and every compartment stores different items, yet everything belongs to one locker. So similarly, one structure object holds multiple members in one continuous memory block. So a structure occupies one continuous block of memory containing all of its members. And now that we know how structures are stored, let's learn different ways to give them values. Coming here, initializing structures variable. So filling all members at the time of creation. Like initialization example here is given to you. Just like normal variables, structure variables can also be initialized at creation. See this example. I've also done this in VS Code also. You must have understood. But for extra information, I am explaining that instead of assigning every member separately, we can initialize all members at once. Advantages here are cleaner code, faster initialization, better readability. A real life analogy of the same can be taken as registration form. So imagine filling registration form, every field must receive the correct information in correct order. A empty student card doesn't count and filled student card counts. So just like filling a form creates a complete record, initialization creates a complete object. Note initialization fills every member when the object is created. But what if information changes after initialization? So let's learn how to update members. So updating structure members, or we can say modifying individual members after creation. Simply information changes over time, structures allow us to update individual members. So if example student changes branch, student improves CGPA, student changes phone number, the code now again becomes s1.cgp, s1.branch, so then the value given will be updated. So if we select one single member, the remaining members stay exactly the same. So structure allows selective modification. But there are some mistakes that beginners make, like forgetting the dot operator, updating wrong object, thinking all members change when one is updated. So remember only the target in member is modified, all other members remain untouched. So we can modify one member without changing the entire structure. So if one object can store one student information, how do we manage hundred of students? That's where creating multiple structure objects comes. Multiple student, multiple structure objects like one structure blueprint can create many independent objects. Example student S1, S2, S3 and so much more up to infinity you can take. An illustration you can take S1 is Rahul, S2 is Ajiti, S3 is Karan and so much more. So creating multiple structure objects is so easy and so much easy to handle in coding. Important observation is every object has its own memory. objects are independent, modifying one never affects other. These three are very important points. But some mistake students often think like all objects share the same data that they do not. Real life analogy like you can say apartments, like one building blueprint and above it forms hundreds of apartments. Every apartment contains different families, same structure, completely different data. So one blueprint, unlimited independent objects. So, but if we want to create a copy of one student information into another object, so here it is, copying one structure to another. So copying one structure to another, like duplicating complete objects in one statement. Like structure copy operation, C++ allows us to copy one complete structure into another. Example, student S2 is equal to S1. Similarly, every member is copied automatically, name is copied, roll number copied, CGPA, section, everything copied. So after copying, both objects become independent. Changing one later also does not affect other. Like important observation you can take, the copy operation. The copy operation duplicates every member. No manual copying is required. Both objects are completely separate after copy. Some mistakes beginner understand like student often think both variables point to same object, but actually they are two completely separate objects. A real life analogy you can take photocopy. The original and copy contains the same information but changing one does not modify other. So far we have worked with individual objects. Next we are going to manage hundred of record with array of structures. So you might question arise that why do we need arrays of structures? Because we need to manage thousands of records efficiently. The problem till now is coming that student S1, student S2, student S3, this works for a few records. But what if a college has 5,000 students? So will I be writing like student S1, S2, S3 all the way till student 5 S5000? Come on, that's not how we should do. That's not a practical way, and that's also not a good way to do coding. So, and that's difficult also and can take hours of my work. But while if we do with array of structures, it is just like 5 to 10 minutes of work. So this approach is impossible to write and to maintain also and to manage also. So for this we have solution like array of structures. So key insights are just as an array stores multiple integers, array of structure stores multiple objects. Advantage is it organizes large collection of records, easy to manage, search and update, used in real world software, scales to thousands of records. A real life analogy you can take as classroom. One thing you should understand that array of structures allows us to manage multiple objects efficiently. So how do we actually create an array of structures? So here we go. Creating an array of structures and declaring array that holds complete structure objects. Syntax and explanation. Creating an array of structures is similar to creating an array of integers. Example, students 100. Breakdown here is student is data type, students is array name, and 100 is number of student objects. So every element of the array is complete student object with all its members. Student 0 is name roll number CGP branch, 1 is name roll CGP branch, 2 is same, 3 go on, go on, go on. So advantages and observations are easy to access any student by index, efficient memory layout, easy to organize and iterate. Some common beginner mistakes are students often think each element stores only one variable, but actually each element stores one complete structure with all members. Real life analogy like filling cabinet. A filling cabinet with 100 drawers. Each drawer contains one complete student file with all their details. So cabinet 0 is complete, 1 is complete, similarly continues. So each element is an independent structure object. So now that we have learned the and created the array of structures, that's how to learn how to fill it with data. So coming back to VS Code, and I will explain all of it to you on VS Code. So here, so now, so here I created a structure student. I will say string name int roll, and now end it, and after it inside int main I will say student s3, which means we are having 3 students values. So we will simply take a for loop. We will say for int I equal to 0, I less than 3, I plus plus, and we will say user that to enter the name, and here below I will take C in with s of I dot name. Simply I will take cout enter roll number, and I will simply take C in s of I dot roll number dot roll. So after doing this, our for loop work is done. We will simply say cout. Outside the loop we will say cout slash n student details, again slash n, and now below this we will take another for loop for I equal to 0, I less than 3, I plus plus, cout, and inside cout is the main thing, which is s of I dot name, and then these brackets, a space here, and then s dot s of I dot roll, and after this s of I dot roll we will simply say end of line, and that's it. Our code is done. So now when I run the code, wait, I will run again in new terminal. Yes. So running the code, here firstly it asks for enter name. We'll say Rahul 101. Shivansh 102. Aryan 103. So it simply gives the student details as Rahul 101, Shivansh 102, Aryan 103. So that's how nicely it gives the output of complete structure, and that's so easy to do instead of writing 500 times. I hope you understood. Now coming back to our presentation, take an input for an array of structures using loops to fill hundreds of records efficiently. The solution is loops. Loops, current student, input name, input role, input CGP and repeat. So every iteration fills one complete student object. So I do the same work in the code. I hope you understood because it saves times. It helps to make a cleaner code, easy to expand to any number of students. But there are some common beginner mistakes like incorrect loop limits, accessing wrong array index, forgetting the dot operator. So loops makes array of structure practical. Once all student records are stored, how do we display them? So displaying record from an array of structures, retrieving and presenting stored data using loops. So here displaying with loops. So after storing data, the next step is retrieving and displaying it. So again loops become our best friend. Workflow is loop, current student, read members, display details, repeat. So applications are student list, employee reports, hospital records, customer databases. The advantages and observations are organized output, fast retrieval, easy reporting. The same loop technique works for arrays of structures just like normal arrays. But there are common beginner mistakes like students sometimes print only one member instead of complete object. A real life analogy like report card day. On report card day, the teacher reads out each student's complete record one by one. Student 1, all details, student 2, all details, student n, all details. So, displaying record simply means displaying every member of every object. If we can display every student, can we also search for a particular one? So yeah, searching for a record, finding specific records using loops and conditions. So this is very good thing, like we have to find particular things using loops and conditions. So here it has some advantages like fast access to information or foundation of database programming or used in almost every management system. Some real life application like college management, hospital management, library system, apply, employee portals, online booking, and etc. are all examples of it. So common beginner mistakes that are here for it is that comparing the wrong member, forgetting to stop after finding the record, incorrect loop conditions, not handling record, not found case. So always validate your search logic before running on large datasets. The search workflow here is real world software rarely displays all records. Usually users search for one specific record. Either search by roll number, name, department, registration number. So workflow is start loop, compare current record, match. If yes is then display record, no then continue searching. That's how easy it is. Searching means checking each object until the required information is found. So why use function with structures? Because organizing repeated operations on structured data, it helps in it. So better code organization is used, code reusability is given, reduced repetition, easier debugging, easier maintenance. So real life analogy, like imagine a receptionist at the college. Instead of every teacher collecting student details, the receptionist performs that task once for everyone. So the work is centralized and reusable. The important observation here is structure store the data, functions perform operations on that data. So how do we pass an entire structure to a function? So here you go. Passing a structure to a function. Sending a complete object instead of individual variables like introduction and explanation. So instead of passing individual variable, we can pass one complete structure object. Example display student with S. Workflow simple. Student is an object function is called, entire structure is passed, and displays members. So student object displays student and then outputs members. Advantage is cleaner code, fewer parameters, easier to understand, better programming design. Interview tip for you is passing one structure is usually much cleaner than passing many separate variables. A common beginner mistake is forgetting the structured data type in the parameter list, using incorrect member names. So instead of handing someone separate sheets, you hand them the complete student file. A complete object can be passed to a function just like any other variable. So let me show you this in VS Code also. So here commenting all of the work done before. In main. So here in the code, we will simply take a structure student that's it, string name int role, and now I will take another void display name function. So inside this void display we will take student as parameter. So I will say cout s dot name end of line cout s dot role end of line. So after doing this, inside int main, now we will come to int main, we will say student S1 is equal to Rahul 101, and below this student S1 is equal to Rahul 101. I will say display S1. I will take it in double strings. So that's it. Now running the code, it says Rahul 101, and that's so nice. This is how we do it. I hope you understood. Coming back to our presentation now. So returning a structure from a function. Like function can return complete structure objects, not just simple values. Like functions are not limited to returning integers or floating point values. They can also return complete structure objects. So example student create student. The function prepares a student object. The completed object is returned to the caller. Workflow is function create object, fill members, return object, main program. So applications use a registration system, banking software, employee portals, hospital management. There are so many applications. Advantages you also know. Interview tip also know. Common beginner mistake I should tell you. Returning incomplete objects and forgetting the return statement. You can take a factory assembly as a real life analogy that builds a complete product and ships it out. Function creates a fill, returns object and creates and fills, and return object and comes back to main program. So functions can create and return complete real world objects. So I just did it before. So if structure and functions work together so well, can structure also contain other structures? So answer is yes. Nested structures, a very good and very complex topic. These forms a very good level of DSA question asked in very top companies out there. So structure can contain other structures to model complex real world objects. So introduction. Real world objects are often made of smaller related objects, but structure allow one structure to contain another. So the hierarchy here is that student is a structure, address is another structure. So city and state and pin are stored in address of the student. So instead of placing every address field directly inside student, we create a separate address structure. Then student contains one address member. So access syntax is student.address.city. That's a very good thing to understand. Student.address.city. The outer one is comes the first. So employees, example like employee office address, hospital patient home address, bank customer permanent address. So it has advantages like better organization, code reusability, cleaner design, easy maintenance. And nested structures show you understand how to model hierarchy real world data cleanly. But there are some common beginner mistakes like confusing nested members, or forgetting multiple dot operators. Real life analogy like a student ID card that contains a separate address card inside it. So nested structure represent complex real world objects naturally. So let me show you this in VS Code for better understanding. So here in the code, firstly let me make a structure. I will make struct address first, and inside struct address I will say string city, and another thing to include I will say string state. So that much is done. After doing this, I will also add terminator there, like this. It marks the end of that structure. Now I will take struct student, string name. Besides string name, I will take int role and address addr here. So after forming these two structures, we will simply come to int main and say student s, and below this I will say s dot name is Rahul, s dot role is 101. So after declaring these two things, I will say s dot addr dot city is equal to Delhi, and I will say s dot addr dot state is also Delhi. So after doing these two things, I will simply say cout s dot name end of line cout s dot, after taking s dot name I will say cout s dot addr dot city and another cout. So that's pretty so that's pretty much it. So now when I run the code, simply says Rahul as the name and Delhi as city and state over here. So required things are done. The code is so much organized in a such a nicer way. Then the doing it for one student and doing for 1,000 students doesn't makes much changes now. Only just to add the value of s dot name, s dot role, or this s dot addr dot city and state. That's it. The main thinking, main logic is so easy for it. And coming back to our presentation now, some real world application of structures, student management systems, hospital management systems, banking software, e-commerce platform, library management, employee management, vehicle registration, airline reservation systems. So structures are the bridge between procedural programming and object-oriented programming. So now that we have mastered structures, let's review common mistakes, test our understanding and discover how structures naturally evolve into classes and objects in the next part of our journey. So some common mistakes beginners make with structures. Forgetting dot operator, using incorrect member name, forgetting to create a structure object, mixing data types, leaving member uninitialized, accessing members before assigning values. So why these mistakes occur? because most errors happen because students confuse the structure definition with structure object. So the blueprint is not the building. Best practices are always initialize members, use meaningful member names, create objects before using them, keep related information together. So correct versus common mistakes. These are correct, but these are common mistakes you do. Same here, same here. So structures define a blueprint, object stores the actual data. So let's understand what actually happens inside memory when we create a structure. So structure inside computer memory. So when we take a student object with name, roll number, CGPA section, the how it works is student s1 s1 dot name gets the memory block 1, s1 dot roll the next one gets 2, similarly 3 and 4. So all blocks are adjacent in RAM. So one object is equal to multiple memory location grouped together only. So now that we have understood memory, let's compare structures with the concept we have already learned. So variables versus arrays versus structures. Each data storage technique solves a different problems. Variable stores one value, array stores many values, structure stores many related values. Variable has one data type, array has same data type, structures can have different data types. This is an example of a variable, this is example of array, this is example of student of structure. So single information, collection of similar information, collection of related information. So each concept builds upon the previous one. Firstly, I understand you variable, then I explained you arrays, now I explained you structure. So you have to use the right data structure for right problem. So how do interviewers test your understanding of structures? So interviews and viva questions or structures. Here are some common interview questions that are mostly asked in interviews, like what is structure, why do we use structures, what is a member, what is structure variable, what is a dot operator, how are arrays and structure different, can a structure contain another structure, why are structures important. So with all of these questions, this presentation is available in our pinned comment and also description. If you want it, do let me know. So always explain using practical examples instead of memorizing definitions. So you understand the why. So understanding concepts is more valuable than memorizing definitions. So let's see how all these concepts came together in one practical project. So a mini project preview, student management system. It combines everything you have learned into one practical project. These are the features for it. These are the concepts used, and this is the learning outcome that this project demonstrates how structures are used in real world software development. So do solve the mini problem yourself and give me your code in the comment section. I will review it and explain you if it's correct, it's wrong, or what should be suggestion by my side. So a dashboard preview like college management, school ERP, student portal, online registration, all of this is done. So project transform concepts into real programming skills. Do pause the video and try to do this yourself. Coming next, best practices while using structures. We use meaningful structure names, use meaningful member names, group only related information, keep structure simple and focused, initialize member whenever possible, avoid unnecessary duplicate structures, organize structures before writing program logic. Advantages here are better readability, easier teamwork, easier debugging, professional coding style. So think of organizing files in folders. So well organized folders make information easier to find. So why this matters? Because good structured design makes programs easier to understand and maintain. So well designed structures lead to well designed programs. So let's see how structures solve real-world software problems. Case study: Student management system. Let's connect structure with a real application. Like system features here are these. How structure help? So instead of creating many unrelated variables, one student structure organizes everything. So most management software start with organized records. So if structures are so useful, why do we need object-oriented programming? So let me explain. Limitation of structures are also there. So current limitations are structure organize data, but they do not organize the functions. They operate on that data only. Like an example, student has name, roll number, CGPA, but function remains outside. The display, update and calculate grade are outside. So as program becomes larger, keeping data and related functions separate makes program harder to maintain. So the important observation here is that in comparison, structure has only data and OOP has data plus functions, and which is the future of coding. So, so understand why OOP was introduced is more valuable than simply memorizing definitions. One thing to know, structure groups data, OOP groups data and behavior. So how can programming become even more organized? So it can become with OOPs oriented programming, object oriented programming, OOPs. So, complete revision mind map. Key learning outcomes here are group related data, create custom data types, organize record, build real world programs. Revision tip for you is if you can explain this roadmap without looking at notes, you have understood structures. This is complete roadmap. Try to understand and understood me in the comment sections. So, episode 14 summary. In this episode, we have covered definition and declaration, access and manipulation, memory organization, arrays and functions, nesting and composition, real-world applications, best practices and limitations. So, revision transforms information into long-term memory. So let's finish today's journey with one final message. Congratulations, you can now build real-world records. You have completed one of the most important milestones in procedural programming. Today you learned all of these things. What this means is that you can now design data models for all of students, employees, hospital, banks, libraries, inventory systems. Next episode is object-oriented programming with classes and objects. So if structures can organize data so well, how can we also organize the function that works on that data? So that will be covered in next episode. So today's lesson prepares you for the next programming paradigm, which is OOPS. So knowledge check. Can you answer these? Before moving ahead, let's quickly test out understanding of structures. So all of these 10 questions are to be written on page and you have to write their answers on the same page. So do try to tell me the answer in comment section. And in case if you have done all of these 10 questions, tell me in the comment section with done. I will understand that my explanation has gone well and I have reached someone and some people and genuinely helped them. So these 10 questions should be done and you should be answerable to all of these 10 questions. A practical challenge is for all of you here are beginners, intermediate and advanced. I recommend to start with beginner only and continue till advanced. Do all these questions because more you program, more you enhance in coding. So the more you programs you write, the more natural structure becomes. So let's look at the complete journey you have completed so far. Oh wow, your learning roadmap looks like this. Such a nice one. I mean, skills you have built are program, problem solving, logic building, memory understanding, data organization, Modular programming, real-world record management. Key insight is every topic you have learned prepares you for next one. So programming mastery is built one concept at a time. So coming next is object-oriented programming. So congratulations, it's done, and this is the last 2 minutes for the episode. Like the best way to learn programming is not to watch code, it's to write code. So do try to code. And one thing I would like to tell you at the last here is that congratulations, you have just learned one of the most important building blocks of modern C++. Today you learned what structures are, the struct keyword, creating and using structured objects, dot operator, structure initialization, array of structures, passing structure to function, nested structure. So remember, structures aren't just about grouping data, they are your first step towards designing real-world programs. And in next episode, we will take that idea even further by learning object-oriented programming, where you will discover classes, objects, constructor, inheritance, polymorphism, encapsulation, and the concepts used in professional software development. So if this video helped you, like, share, and subscribe to ShivCore so you don't miss the biggest episode of the entire C++ series. Until then, master the core, build the future, and signing off, ShivCore.